5.4 is about dividing polynomials. So the first problem is just like a precursor to why this stuff works, and it's not really that big of a deal, but I do want, and it's the only time you need to do it, which this problem's kind of pointless because you have x plus 5, but with stuff that's bigger than a linear term or a linear binomial, you have to do this. So x plus 5, again, old school division, 4x squared plus 23x minus 16, okay? Well, since there's two terms, I need to go to the second term here, okay? And I'm going to look at the first term and the first term. How do I get x to be 4x squared? Well, I need to multiply it by 4x. Why? Because 4x times x is 4x squared. I need the first term to be the same. And then do whatever comes next. So 4x times 5 is 20x. And now we subtract. Okay, so what's 4x squared minus x squared? It's gone, hence why we're dividing like that. 23x minus 20x is 3x. And then bring down that 16. Bring that down. Okay, so now how do I make x be 3x? Okay, well, 3 times x is 3x, so I'm going to multiply by 3 here, or divide by 3, I'm sorry. Then 3 times x is 3x. 3 times 5 is 15. Subtract. That cancels again, which is what I'm trying to do. And I get negative 16 minus 15 gives me a negative 31. So negative 31 being my remainder, okay, that's my remainder. Now, what your answer then would be, when you divide 4x squared plus 23x minus 16 by x plus 5, you're left with 4x plus 3 minus 31, divided by, and then your original divisor, x plus 5. Checking factors, and here's where long division really comes in handy because you have to be able to do it when that's an x squared term. So I'm going to write that here, x squared plus 1 into 3x to the 4th minus 4x cubed plus 12x squared. Notice I'm missing an x. I'm actually going to write the 0x in there because I want to represent that as we divide through this. Okay, and if we're seeing it as a factor, it should be divided into it. So how do I get x squared to be 3x to the 4th? Well, I'm going to multiply by 3x squared. Okay, so 3x squared. Now line it up with what you have here. So x squared over x squared. So 3x squared times x squared is 3x to the 4th. Perfect. Okay, well, we don't have an x cubed, so we'll talk about 0x cubed. And then 3x squared times 1 is plus 3x squared. Subtract. Gone. Negative 4x cubed minus, that is negative 4x cubed. 12x squared minus 3x squared is 9x squared. Bring down your 0x. How do I make x squared be 4x cubed? I need to multiply by negative 4x. Why? Because negative 4x times x squared is negative 4x cubed. Negative 4x times 1 is negative 4x. Well, what comes under x squared? Well, we're going to have a 0x squared here. Now we're going to subtract them all. Those cancel. I'm still left with 9x squared here. That minus negative 4x is positive 4x. Okay, how do I get x squared to be 9x squared? I'm going to multiply by 9. 9 times x squared is 9x squared. 9 times 1 is 9. We got a 0x in here. Subtract again. That's gone. We end up with 4x minus 9. Sorry, I forgot to bring the 5 down. So it should be minus 4. Okay. And that's the end. It is not a factor because we are left with this remainder at the bottom. So your answer is no. Again, I wouldn't worry too much about that stuff. I would worry more so about this synthetic division, okay? This is how we're going to end up solving when we find real roots to help us find irrational roots and things like that. So that's what I want to concentrate on is the synthetic division. So when I'm dividing by x plus 2, I'm going to take the opposite of that, so negative 2, put it in a box. And I'm going to take every coefficient here and write it afterwards. So 1, negative 14, 51, negative 54. Okay. So you start out by bringing the first number down, so 1. To get up, you multiply. So 1 times 1 gives, or I'm sorry, negative 2 times 1 gives me negative 2. To get down, okay, you add. So we're adding here. So negative 14 plus negative 13, negative 3, I'm sorry, is negative 17. Well, I'm dumb, sorry. Negative 2 times 1 is not negative 3. It's negative 2. So add them, that gives me negative 16. Now multiply. Negative 2 times negative 16 is positive 32. Now add them, that gives me 83. Okay, negative 2 times 83, because we're going to remember we're multiplying. Negative 2 times 83 is negative 166. And now we're going to add those together, and you get negative 220. Okay, so what is my answer here? Once we divide that, we're left with x squared minus 16x plus 83 minus 220 over our original divisor, which was x plus 2. That is our final answer. Synthetic division also works when you're trying to find p of 3. Now, we've talked about this before. You could really straight plug this in, right straight in your calculator and go from there, but it's good to practice this stuff. So 1 is my first coefficient. I'm missing x to the 4th, so I need to put a 0 placeholder. X cubed is negative 2. X squared is negative 1. I'm missing an x, so I have to put a placeholder, and then 2. I'm going to bring the first number down. 1. 3 times 1 is 3, and we're going to add. Remember, we multiply to get up, add to go down. Okay? So 0 plus 3 is 3. It's harder to get up. I always think about it getting up in the morning. It's hard to get up in the morning, so we have to multiply to get up. It's a stronger power than addition. It's always what I remember it. 3 times 3 is 9. Add 9 plus negative 2 is 7. That gives me 21. Add, that gives me 20. Multiply, that gives me 60. Add again, that gives me 60. 3 times 60 is 180. Add for 182. Okay, so what they're saying is that P of 3 equals 182. And again, if you plug that in your calculator, that's what you get anyways, but synthetic division sometimes is easier.